So here we start with characterizing one-dimensional motion. Okay, first we need to discuss terms like position, frame of reference, path length, displacement, etc. Frame of reference is a term we need to discuss. First, what is position? Position means what? Very simple. It is the point where an object is situated. Okay, so how you characterize position with the help of coordinate axis. Okay, you will use certain units to specify the position. Okay, as I was telling the case with the bead, at t equal to 1 second, the bead is at x equal to 2 centimeter. Stating like that, we say as position. Now coming to the term frame of reference. Frame of reference means a platform of observation. Platform of observation means what? See, as I said, you are sitting in the car. Suppose the car is at rest. Okay, you are looking outside. You can see some objects at rest and you can see some other objects being in motion, some vehicles in motion. So you are sitting in the car and looking outside. So sitting in the car, that car is a frame of reference actually. Okay, and when the car starts moving, the frame of reference also is moving, and with respect to that you can state the state of rest or state of motion of other objects. So the platform of observation is generally called as frame of reference. As you can see in this picture, a train, the passenger is standing in the platform and the train is moving. Okay, so platform, it is at rest, that platform is a frame of reference. In the second case, the person is standing in the train, okay, and he is observing. So the train has become the frame of reference. So the thing is this, a platform of observation, we call it as frame of reference. But when we come to the general terms, no, frame of reference, actually how we take a frame of reference actually, it is usually considered as origin and position of moving object given by the x, y, z coordinate. So in motion in one dimension we take only x coordinate. So with the proper coordinate system and origin, we can specify the state of rest or state of motion. That way we fix the frame of reference. So don't be confused with the word frame of reference. So frame of reference simply means what? A platform of observation. Only that much we need now. Here we discuss the two terms path length and displacement. What is meant by path length? Path length means it is the length of the path covered by the body. It is otherwise called as distance. So path length or distance. We can use any term, no problem, and it means the length of the path covered by the body. And what type of quantity it is, scalar or vector? What do you mean by scalar and vector quantities? The quantities which do not require direction, or the quantities which has magnitude alone, such quantities are called scalar quantities. And vector quantities means they have both direction and magnitude. Such quantities are called vector quantity. So path length or distance is a scalar quantity and it will always be positive. The path length will always be positive. We'll explain it with the help of example. Displacement means what? Displacement means the change in position. Displacement is the change in position. So if x1 is the position of an object at time t1 and x2 at time t2, then displacement represented by delta x. So displacement is represented by delta x. Delta x is equal to x2 minus x1, that is final position minus initial position. So if you know the positions of an object at two instants of time t1 and t2, the change in positions gives you the displacement. And you know, displacement is a vector quantity. It has both direction and magnitude. Okay, so when we speak about direction, how we incorporate direction in one-dimensional motion? As I said earlier, in one-dimensional motion, there are only two possibilities. If the object is moving in horizontal direction, the object can move either towards right or towards left. If the object is moving in vertical direction, it can either go up or down. So in one dimensional motion, always there are only two possibilities. So direction, only two possibility means it is very easy to incorporate that direction by associating positive and negative sign. So by using this positive and negative sign, we will be showing the direction in one dimensional motion. So in horizontal direction, towards right means we will take as positive, towards left we will take as negative. In up and down motion, that means upward direction we consider as positive and downward direction we consider as negative. Okay, so that's what the what path length and displacement. Let's explain these terms more with the help of example. We consider an example. In this example, the origin and the positions of the car at different times are shown. Origin means what? The starting point. That means the position from where the object starts. Okay. Now, P, Q, R, they are the different positions of the object at different instants of time. Suppose we consider the motion of the car from O to P. Okay, so initial position is O and final position is P. So P, it is at 360 meter, origin is at 0. Okay, so for the motion from O to P, what is the path length or distance traveled? Path length or distance traveled is the length of the path traveled. So it is what? 360 meter. So path length, I am writing PL, path length is equal to what? 360 meter. Okay. Now, for the same path, for the same motion from O to P, you consider the displacement delta x is equal to, what is displacement? It is final position minus initial position, which is final position. Final position is 360 meter. So 360 minus what? Initial position is what? 0. So minus 0. So what is our displacement? Displacement is 360 meter. Got it? So path length and displacement are same in this case for the motion from O to P. Now we consider another motion, that is from O to Q. So for the motion from O to Q, O to Q means what? It starts from O, it goes to P, then goes to Q. That is the path actually. O to P, okay, O to P it goes, then it comes back to Q. Okay, so for that motion, what will be the displacement and path length? So we are considering which one? We are considering OQ. So let's deal with path length first. What is path length? Path length means, so it starts from O to P. Okay, so 360 meter is there. Then from P it goes to Q. So how much is the distance from 360 to 240? That distance is 120. So path length means it becomes OP plus PQ. OP plus PQ. So it will be 360 plus 120, that is equal to 480. So for this motion, the path length is 480 meter. Okay. Now let's see what about the displacement. So displacement delta x is equal to final position minus initial position. Where is the final position? Final position is Q. and initial position is 0 or origin. So what is the change in position? 240 minus 0, that is, it is equal to 240. Is that clear? So what is the displacement in this case? 240 meter. So path length or distance we got as 480 meter and displacement we got as 240 meter. So are they same? No. But for the path OP, for the motion from O to P, we got both the displacement and distance to be same. That is magnitude of displacement and the path length to be same. Here magnitude of displacement is 240 meter, path length is 480 meter, both are different. Okay. Now we consider another motion. That means we consider the motion from O to R. O to R means it goes to P, then comes to Q, then to R. So what did I say? It goes to, so we have, it goes to O, from O to P, then from P to Q, then from Q to R it goes. Okay, so the thing is this, P and Q, they lie on right hand side and R lies on left hand side. So for this motion, what will be the path length? Path length will be what? So as I said, it goes to P, then from P to Q, then Q to O, then only it goes to R. Okay, so O to P, what is the distance? O to P, it is 360. Then from P to Q, 120. From Q to O, it is 240. Okay, plus. Then from O to R, it is again 120. So let me ask whether you need to consider this minus sign here. No. In finding what distance or path length, you need not look at that. You need to find out only or consider only the what length, not sign. So what is the sum of all these things? 360 plus 480. So path length becomes 840 meter. So that is the path length for the motion, which one? O to R. O to R means not directly from O to R, O to P, then to R. Okay. Now what about the displacement? That displacement delta x is equal to what? What will be the displacement? Displacement, it is final position minus initial position, that is minus 120 minus R, that means origin, that is 0. So you will get it as minus 120 meter. Okay, so here the displacement is minus. Got it? So for the motion O to R, path length is 840 meter and the displacement is 120 meter. Displacement is minus 120 meter and path length is 840 meter. So this case also the magnitude of displacement is not equal to the path length. Okay, not only this, another conclusion we got, that is we discussed the case with what positive displacement and now we got the displacement to be negative. So displacement can be positive or negative, and what does that positive or negative sign shows? The positive and negative sign shows the direction. Okay, so positive displacement, positive means what? The object was moving in positive direction. That means towards right it was moving. Okay, in this direction it was moving. Got it? Then when the displacement is negative, it means the object is moving in negative direction. So displacement can be positive or negative, and positive and negative sign shows the direction. Once again, we make comparison between displacement and distance. So what is distance? It is the actual path traversed by the body, and displacement is the difference in initial and final position. and distance is a scalar quantity, displacement is a vector quantity. Okay, so the distance will always be positive. Got it? It can never be negative or zero. But displacement can be positive, negative, or zero. So when do we have zero displacement? In that example, if the object starts from O, goes to B, then comes back to O. So initial position is O, final position also is O. So if the final and initial position coincide, the displacement will be equal to 0. But what about the distance traveled? It will not be equal to 0. That is the case with zero displacement. So the displacement can be negative, 0 or positive. Now the next point, that is the distance traveled is either equal or greater than the displacement and is never less than magnitude of displacement. So this is a point to be noted. In the example, first example we discussed, in that case both distance and magnitude of displacement was same. But in the later examples, we got distance to be more than the magnitude of displacement. So that is the actual case. We will never get the reverse thing. That means magnitude of displacement can never be greater than the value of distance. So distance will always be greater than or equal to the magnitude of displacement. Displacement is written within two vertical lines. It means that magnitude. Okay, without considering the sign, we are speaking about that condition. So distance will always be greater than or equal to. Equal to means it can be, as we discussed in the first case, it can be equal to, but it will never be greater than. That means magnitude of displacement will never be greater than distance. Got it? Then distance depends on path traveled. But what about displacement? Displacement is independent of path followed. It depends only on initial and final position, because displacement is defined in such a way that is, it is the difference in initial and final position. So here we have a special case, that is the zero displacement. I already explained. So the thing is this: if the body starts traveling, it starts from its position and it travels some distance and comes back to the initial position. So what is the case? Initial position and final position coincide. So when we find the difference, it will be equal to 0 and displacement will be equal to 0. So in such a case, displacement will be equal to 0. And in circular motion, generally we say the what displacement is 0. So these are the two cases where we have 0 displacement. So that is a point to be noted. Now coming to uniform motion and non-uniform motion. I hope you are familiar with these terms. A body is said to be in uniform motion if it travels equal distances in equal intervals of time along a straight line, however small these intervals may be. Okay, so if it covers equal distances in equal intervals of time, we say the body is in uniform motion. So for example, it's given a car running at a constant speed 10 meter per second. It will be covering same distance in equal intervals always. So that is what is shown here, and as per that a graph is drawn. Position, here it is shown distance time graph. We will discuss what position time graph. So time is taken along x-axis and distance is taken along y-axis. So we'll have the graph like this. Okay. Now certain examples of uniform motion again given: aeroplane flying at a speed 600 km per hour, a train running at a speed 120 km per hour, and light energy traveling at a speed 3 into 10 raised to 8, and a spaceship moving at a speed 100 km per second. All are said to be in what? Uniform motion. Now when will you say that a particular object is in non-uniform motion? Non-uniform motion means if the object travels unequal distances in equal intervals of time. So in equal intervals, the object is traveling unequal distance. We call it as what? Non-uniform motion. Example, when a ball is dropped or when a stone is dropped from a height, the movement of that stone is non-uniform motion. There are many other examples also. We have what the aeroplane running at a runway before takeoff, a freely falling body, and an object thrown vertically upward. All these are what examples of non-uniform motion. When the brakes are applied, the motion of a vehicle, that is an example of non-uniform motion. So if we draw distance time graph, you will get the graph like this. Okay, curved graph. Now one type of graph we will be discussing, that is position time graph. So position time graph means what? Time is taken along x-axis and x-axis, and position is taken along y-axis. That's what we mean by position time graph. For a stationary object, there is no change in position with respect to time. So we have a graph like this which is parallel to x-axis. So this shows a position time graph of a stationary object. Next, for a uniform motion, the graph will be like this. That is, it covers equal distances in equal intervals of time now. So when we draw the position time graph, for uniform motion, the graph will be a straight line like this. Now for non-uniform motion, it will not be a straight line like the case of stationary object or uniform motion. It will be a curved one. Okay, there can be any curvature. There is no specific curvature for a non-uniform motion. It can be in any shape. So a curved position time graph shows non-uniform motion. So in both ways you should learn. That is, if somebody asks you what is the shape of the graph, you should be able to say. If the shape of the graph is given, you should be able to identify the type of motion also. Okay, so further graphs we will be discussing, we will be studying in this chapter. So you should be thorough with each and every graph. So hope you followed today's session. So only this much. Thank you.